39. We've got just enough time. There is one last little topic. One last little thing that I was worried we weren't going to get to before the unit test. And we're at least going to get to play around with this a little bit. I think for the most part you guys are going to be okay. You know, those College Board folks, they are tricky and really good at what they do. Their goal every single year when they write the test, and I want to be on this committee that writes the test. Jackie, if I'm over here, can everybody see? Mm-hmm. Their goal is to take things that you already know and tweak it a little bit. Not make it impossible, but push the ideas a little bit. So, here's the instructions. We're going to match each verbal description, so your verbal description in the first column, to the corresponding data table. When you're finished, use the information in the data table to estimate the value of the derivative at x equals 1. For all these problems, assume that f is twice differentiable on the open interval -2 to 2. You guys all know what differentiable means. Differentiable means the derivative exists. And for a derivative to exist, the function has to be continuous. There can be no jumps, no holes. That's all saying continuous, right? But it's not just that.
The limit from the left and limit from the right.
Right, we want to look at limit from the left and limit from the right on the derivative. You can have no vertical tangent lines. Vertical tangent lines. And one more thing. There's one more thing you look at on the graph to make sure you're differentiable. We always say differentiable means smooth. The function has to be continuous. There can be no cusp points, and there can be no vertical tangent lines. Okay? If f is twice differentiable, that means that the second derivative exists as well. All right, so let's look at this first verbal description. For all values of x in the interval -2 less than or equal to x less than or equal to 2, the first derivative is positive. First derivative is positive, okay. F prime positive. And the first derivative increasing. Now I'm pretty sure that if I asked any one of the 16 of you right now, what does this mean about the graph? If this was a multiple choice matching sort of thing, you've got this information about f prime. What do we know about f? Have a quick conversation with somebody near you. What do you know about the graph of f? Not f prime. F prime is positive. F has to be... Careful. F prime, the derivative is positive, so f has to be increasing, and f has to be concave up. And I heard the concave up, I think before I heard anything else, everybody's like, oh, concave up. We're okay, you have to be increasing and concave up?
Yes.
So what does that look like? Draw them in the air for me. Increasing and concave up. I want to make sure we know, like, what would you look for on the graph? Increasing and concave up ought to look something like that. We're okay? On the graph, this is an easy question. Multiple choice, everyone is going to get this question right. But those tricky College Board people are going to push the question a little bit more. We know f prime positive and f prime increasing means f is increasing concave up, and we can find the graph. But look at the data tables. Is there anything in the data table? Which of those 5 are you going to pick? You're looking for increasing and concave up.
Right.
And even if you don't know which one to pick, I'm curious if there are things that we know to get rid of. Roberto, what do you want to get rid of?
Get rid of D.
D? Tell me what you want to get rid of D.
Because f of x is decreasing instead of
We're looking at f of x. The y values are 4, 2, -1, -5, -10. Is everybody okay? That's decreasing? Okay, so this guy here is decreasing. All I have to do is look at those y values. I'm not going to pick D. Kaylin.
You could get rid of A.
You want to get rid of A? Tell me why you want to get rid of A.
Because it's also decreasing.
Those y values, 3, -1, -4, -6, -7, also decreasing. Okay, I get rid of A, and I would hope just about everybody in the room is going to get rid of these options right away. What about B, C, and E? -3, -2, 0, 3, 7. Those y values are increasing. -11, -9, those are increasing. All the rest are increasing. What else?
Wait, couldn't you eliminate C because they're all negative?
They're all negative. I think maybe Jackie last period mentioned that. -11, -9, -7, -5, -3. Those are all negative. But they're actually still increasing. If you think about plotting points, -11 is like way far down. -9, -7, -5, -3. They are increasing. Okay. The last part has to do with the bending of the graph. And we haven't had a lot of conversation here. But if your graph is concave up, something happens with the slopes. What happens with those slopes?
Steeper.
They're getting steeper. They are increasing. The way that you guys found slope back in the day in like 8th grade, what you would look at is you'd look at the table and you'd look at the changes, right? You'd say, over here I'm increasing by 1. What's happening over here? Increasing by 1. Over here, increase by 1. Over here, by 2. Increase by 1. Increase by 3. Increase by 1. Increase by 4. What's happening to the changes? They're getting steeper. You move over the same amount every single time, but you go up more than you did before. You're going up higher and higher and higher. You're getting steeper. That's what this concave up business is all about. As you change, as you move to the right, you go up higher, 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 higher. That's why you're concave up. So I'd look at the changes, and I'd say that the changes are increasing. Are we kind of okay with this idea? Okay. Derivative is just talking about slope. So option number 1, unless I just totally blew this, goes with B. Everybody go to B? All right, see what you can do with the remaining 4. And then we'll come back and layer on another conversation.
The function is strictly decreasing.
It's not talking about the derivative. It's talking about
Strictly decreasing.
we're not worried about
And now that I asked you, you said yeah.
Oh, I thought you said you're big. Sorry.
So isn't 2D?
It would have to be bigger. And then concave down.
it's like the same idea as this.
Wait.
It's this.
Oh no, the function would be
It's more steeper. It's more steeper once it goes down.
Yeah.
Are you just gonna email the keys?
I already did.
The thing is,
It's going to come into your email at 10:15.
so
Now that means
I want to say yes because it has to get.
Yeah, I'm saying yes.
And this one's going to get steeper. It's just like little movements. They're not as big as.
no. First derivative and second derivative.
That's what I'm saying. Have you guys made any matches?
The first derivative is positive, and the second derivative is negative.
No, I'm talking about this. Hey, if every cancel was like that, and then decreasing the concave.
Have you guys made any matches?
Concave.
Evelyn, thank you for making me a better calculator teacher.
First derivative is positive.
Have you guys made any matches?
Yeah.
For number 2?
Because it's decreasing in f of x. Well, in f of x is decreasing,
Yeah.
and also it's getting steeper.
Right, you want to, so it's not just, like, you're able to look at the y values. I would hope the first part is like just looking at the y values and determining increasing, decreasing. That's the easy part. But then it's a matter of how do you bring in this concavity. And so if little f is concave down, what do we know about the derivative? F prime has to be decreasing. So I need to see that those changes are getting smaller. They have to get smaller. All right, friends. I think most folks had a chance to look at number 2. F is strictly decreasing, and F is concave down. So we know A's decreasing, D's decreasing. Any other ones decreasing?
No.
There's no other ones that are decreasing?
No.
Okay, so it's either A or D. If F is concave down, decreasing and concave down has to look like that, right? So I'm looking for my changes. Look at those changes from +3 to -1. That's -4, -3, -2, -1. The other one where we're decreasing, -2, -3, -4, -5. I need the changes to decrease. So which one? Where are the changes decreasing? Not A. -4, -3, -2, -1. You're actually changing by smaller amounts. -4 is a, wait, what just happened there? -4, -3, -2, -1. Those changes are increasing. Because you're going from big negative numbers to small negative numbers. Those are increasing. My bad, and that's caught on film. Changes here, decrease by 2, decrease by 3, decrease by 4, decrease by 5. You're decreasing by more and more and more every single time. So that's why we're going to go with number 2 is D. Okay, number 3, for all values of x on the interval -2 to 2, the first derivative is positive. F prime positive, second derivative negative. If f prime is positive, I need f to be increasing. F double prime negative means f prime is decreasing. I need y values to increase, but the changes to decrease. Y values increase, changes are decreasing. Which one? Y values are increasing, changes are decreasing. And if I look at those changes, increase by 4, by 3, by 2, by 1, I'm increasing by less every single time. So that is going to be E. For number 4, for all values of x, the function is monotone increasing. So f is increasing. Second derivative is 0.
Max or relative min?
It doesn't necessarily mean relative max or relative min. What it means is that f prime is constant. If your second derivative is 0, then your first derivative had to be a constant of some sort. So where do I have a function that's increasing and the changes are constant? That's going to be C. -11, -9, -7, -5, -3. I know that we're increasing. Those changes, you're increasing by 2 every single time. Last class somebody said, you mean like a linear function? Exactly. So number 4 has to be C. And so process of elimination, A is going to be number 5. All the friends are mostly okay? All right, so one last push, and this is not something I got a chance to do at the last class period, is now I want to estimate the derivative. And so here's the thing. Based on this data table, you guys know that the graph of f is decreasing and the changes are getting less negative, decreasing but less negative should look like that. So this is the graph for A. If here's x equals 1, and what I want to do is I want to approximate the slope of the tangent line at 1, a way to do it is you look at the points around and you connect it with, what kind of lines? If you're connecting two lines on the graph? Secant lines. Okay, the blue, these are my secant lines. So specifically for this graph, if I look at x equals 1, what's the slope of the secant connecting the point before to x equals 1? What's the slope between these 2 points? I, slope between 2 points. Ooh. The slope between these 2 points? Between 0, -4 and 1, -6, change in y, divided by change in x. So the slope here is -2. The slope here, between 1, -6 and 2, -7, that slope is -1. The slope of the tangent line has to be, because of the way the graph is bending, in between those two values. So f prime of 1 has to be between -2 and -1. Whatever the secant, slope of the secant line is before, and the slope of the secant line is after, because the way the graph is bending, the slope of the tangent line has to be in between those two values. It just has to be. And unfortunately, we are out of time. It's a short day. Okay, you guys have